Hello students, we are going to solve a PAVE question paper today. So the first question, it is saying a uniform rod of mass m, length L and area of cross section A is pulled on a frictionless horizontal surface by action of two forces as shown in the figure. Tension in the rod at a distance L by 3 from its left end is. So from here we have to go L by 3, so this will become 2L by 3, and here we have to find tension. So I say the rod is like this again, and this direction force is 2F and this direction force is F. Due to this 2F and F, net force on the rod will be F in that direction, and acceleration, if I find, it will be total force divided by mass, which is acceleration. So acceleration here we got. Now at this point we have to find tension. So I'll break this rod into two parts. This part will be of length L by 3 and this part will be of length 2L by 3. For this part, F is backward, tension is forward, and acceleration of whole rod is A only, so we'll say T minus F is equal to m by 3 into A. Why m by 3? Because this part of rod is of length L by 3, so the mass will also be m by 3. Now A is basically equal to F by m, so we got F by 3. From here, if I find tension, tension will be equal to F plus F by 3, which is 4F by 3. 4F by 3 is option number B, so B will be the answer, and this is how you can solve these types of questions. The second question is saying 2 seconds after projection, a projectile is moving at an angle 60 degree from horizontal. After 1 more second it is moving horizontally. If G is equal to 10, the velocity of projection is. So let us say that the particle was projected like this. Starting from here, I say the velocity given was v, initial angle was theta, and 2 seconds, after 2 seconds it is here. After 2 seconds it is here, velocity might be u, this angle has become 60 degree, and after 3 seconds it is here, and the velocity is v dash here. We know that if after 3 second velocity has become v dash, that means the particle's time period is 6 seconds. So 6 seconds is equal to 2v sine of theta by g. 2 and 2 gone, we have v sine theta is equal to 3g. Here it will be 3. That we got about v sine theta. Now if you check here the velocity horizontal will be u cos 60. Here the velocity horizontal will be v cos theta. Here the velocity upward will be v sin theta. Here it will be u sin 60. Now we know that v sine of theta, which is upward velocity, minus of g into 2 seconds after it has gone there, so g into 2 is equal to now upward velocity, which is u sine of 60. From there I can have, there's a mistake, it is u sine v sine theta. From here v sine theta we already have, it is 3g, so 3g minus 2g is equal to u sine of 60. From here we got g is equal to u into sine 60 is equal to root 3 by 2. And from here u by 2 is equal to g by root 3. And what is u by 2? I can say it is u cos of 60. So at the end what we are getting is u cos 60 is equal to g by root 3. Now one more thing, u cos 60 is same as v cos theta. Why? Because horizontal velocity never changed, so we can say v cos theta is equal to this. Also we have v sin theta, which is 3g from here. So if I have to find v, I'll have to square them both up and then take a root of addition, so it will become 9g square plus g square by 3 in a root. From here 9 will go there, it will become 27. 3 will go there, it will become 9 to 3 27, plus 1 divided by 3 g square in the root, which is 28 by 3 in a root into g. That is the velocity with which the particle was thrown. If you see the options, option number B is matching, so B is the answer, and this is how you can solve these types of questions. Now we are going to solve third question of PAVE exam. Here it is saying A and B are released from rest relative to the lift. Lift is accelerating upward at a rate of 3 meter per second square. Mass of A is 8 and mass of B is 5 kg. Coefficient of friction between A and the fixed block is 0.5. We have to find acceleration of B with respect to lift. So let's say we are moving with respect to lift only. So if I make FBD of A and B, let us say this is A. Now A will have its own weight downward, which is 8g. Due to lift's acceleration upward, it will have a pseudo force downward, which will be 8 into A, which is 3. 3 into 8. It will have an upward normal, a tension rightward from here, and a backward friction because of fixed surface. If we talk about B, B will have its own weight downward, which is 5g. Also, it will have a pseudo force, which is 3 into 5, and upward will be tension. Assuming this block is going this direction and with the acceleration of A, so B will go downward with an acceleration of A, so this will have acceleration of A downward. Now writing the equation, obviously friction is equal to mu into n as it is moving, and n will be equal to this plus this, which is 80 plus 24, which is 104, into mu, which is 0.5, which is equal to 52. So we got our F is equal to 52 Newton. Now for A, we can write equation T minus friction, which is 52, is equal to mass into acceleration, which is 8A. And for B, we can write equation which will be, this is 50, this is 15, which will be 65. So 65 minus tension is equal to mass into acceleration, again 5 into A. If I add this and this equation, I'll have 65 minus 52 is equal to 13A. From here we will have 13 is equal to 13A, that means A is equal to 1 meter per second square. That means the acceleration of A and B block will be 1 meter per second square, which is option number A. This is how you can solve these types of questions. Now we are going to solve fourth question of PAVE exam. The question says if the velocity of a particle traveling along a straight line is given as v is equal to x square minus 4x plus 2, where x is the position of the particle at any instant, then the magnitude of acceleration of the particle at x is equal to 4 is. So velocity we are given with, velocity is equal to x square minus 4x plus 2. From here if we find acceleration, acceleration we know with respect to velocity and displacement is related as v dv by dx. So first we have to find dv by dx from here. If I find dv by dx, it will be differentiation of x square, which is 2x, minus differentiation of 4x, which is 4, and differentiation of constant 2 is 0. Then we have to do v into dv by dx. So v dv by dx, if I find, it will be multiplication of both, which is x square minus 4x plus 2, and then 2x minus 4. And we have to find acceleration at a displacement of 4. So we'll have acceleration is equal to 16, because I put 4 here, minus of 16 again, and then plus 2, and then 2 into 4 minus 4. So from here I'll have 2, and then from here I'll have 4. I got 8. So acceleration will be 8 meter per second square, which is option number D. Now we are going to solve fifth question of PAVE exam. The question says a skier plans to ski a smooth fixed hemisphere of radius r. He starts from rest from a curved smooth surface of height r by h. The angle at which it will leave the hemisphere is. So we'll take this hemisphere itself. Now what we are saying is, if it started from here, it is going down with a velocity of 0. Till this point it is going with a velocity of u, we are assuming. And here its velocity has become v in this direction. Now it is on a hemispherical surface, that is circular motion it will be doing. So it will have an outward pseudo force of mv square by r. Also it will have an inward force of, you see this angle is also theta, so mg cos theta will come this way, I'll just write it as inward force of mg cos theta. Also it will have a normal outward. What do we want is that there should be no contact. That means normal has to become 0. That means mg cos theta has to be equal to mv square by r. That's what we want. Now the relation between v and u, this v and this u, if we find, so the particle has come from here to here, here to here. So from here to here the height difference is, you see, this is r, so this distance here, this will be r cos theta, and this total is r again. So we are left with r minus r cos theta, which is r1 minus cos of theta. So what I can say is, if it has come a distance down, so we'll say final kinetic energy, which is half mv square, minus initial kinetic energy, which is half mv square, is equal to the work done by gravity, which is mgr 1 minus cos of theta. This is how we do it. So we got velocity final, but it is related with initial velocity. Now initial velocity is also not given, but it is coming by a height of r by 4. So what we are saying is, if it comes by a high height of r by 4 downwards, so initial velocity is 0 and final velocity is v square. So we'll say again, u square. So half mu square minus 0 is equal to mgr by 4. Now if we add these two equations, we'll have half mv square is equal to mgr 1 minus cos theta plus mgr by 4. This is half mv square, and from here if I take this r there, it will become mgr cos theta is equal to mv square, and then divide by 2 and then divide by 2. So from here mv square we have, and then we can replace it here. We got mgr by 2 cos theta is equal to mgr minus mgr cos theta plus mgr by 4. This cos theta will come here, will have mgr cos theta 3 by 2, and this will be equal to mgr plus mgr by 4, which is 5 by 4 mgr. Now mgr gone, this 2 gone, this 3 will go there. We'll have cos of theta is equal to 5 by 6. Theta will be equal to cos inverse of 5 by 6. If we see our options, cos inverse of 5 by 6 is available in option number C. So C will be the answer, and this is how you can solve these types of questions. We are going to solve 6th question of PAVE exam. In the 6th question, it is saying block of mass m is initially in equilibrium, which with the help of two identical springs as shown in the figure. The right spring is cut. What is the acceleration of the block immediately after the spring is cut? If the acceleration is a, write the value of 4a. Okay. So what we are saying is, we have this system with us. Assuming this spring will have a tension of T, this spring will also have a tension of T, and the block downward force is mg. The block is in equilibrium, that means total force on the block will be 0, and we can see that this tension's upward component will be T cos 37. This tension's also upward component will be 2T cos 37. Downward is T sin 37. Again downward is T sin 37. So T sin 37, T sin 37 gone. Upward will be 2T cos 37 is equal to mg. From here T will come out to be mg by 2 into cos 37, which is 5 by 4. So 4 will come here. So we got 5 by 8 mg. That is the tension in one spring. Now it is saying, what is the acceleration of the block immediately after cutting the spring? Right spring is cut. If the string is cut, how much force is reduced? So initially the force is 0. Now T force is reduced. So acceleration will be due to that T force only. So what I can say is, acceleration is equal to T by m, the force reduced by mass, which is equal to 5 by 8 into g. Now from here we find 4a, so it will become 5 by 2 into g, and g is equal to 10 only, so 10 by 2 is 5, and 5 we got 25. That means 4a is equal to 25. We have option number B as 25. So B is the answer, and this is how you can solve these types of questions. We are going to solve question number 7 of PAVE exam. Question number 7 is saying if the velocity of the particle is 10 plus 2t square, then average acceleration of the particle between 2 and 5 seconds. So what is average acceleration? We know it is delta v by delta t, which is v2 minus v1 divided by t2 minus t1. v2 at 5 seconds, if I put 5 in here, it will be 10 plus 2 into 25, and then subtraction of v1 which is at 2, so it will be 10 plus 2 into 4, and then divided by time change, which is 3. So it will be 25 minus 4 into 2 by 3, which will give me 21 into 2 by 3, which is 14. So acceleration average will be 14 meter per second, which is option number D. So D is the answer, and this is how you can solve these types of questions. We are doing 8th question of PAVE exam today. In this question, it is saying a stone attached to a string is rotated in a vertical circle such that when it is at the top of the circle, its speed is v, and there is neither tension nor slacking in the string. The speed of the stone when its angular displacement is 120 degree from the lowest point. So let us say this is the vertical circle we are moving in, and at this point it is saying the velocity is v. This is the tension. This is the string we are using, and it is saying there is no slacking nor it is having some tension. T is equal to 0, we can say approximately 0. That means upward force, which is v square by rm, and the downward force of the particle, which is mg, has to be equal. So we got v square by rm is equal to m into g. Gone, will have v is equal to gr in the root. V is equal to root of gr. Now it is saying what will be its velocity when it is at this point. So here we have to find velocity. I'll say it a u, given that this angle is 120 degree, that means this angle is 60 degree. Now you see the particle has gone from this point to this point. How much it has gone up? You see, this distance will be r cos 60, this will be r minus r cos 60. So the height it has increased. I'll say it is h, it is r 1 minus cos of 60. Due to decrement of height, velocity will decrease. Why? Because it is going against the gravity. So or what I can say is half mv square minus half mu square is equal to work done by gravity, which is minus of mgr 1 minus cos 60. So from here m gone, I'll have u square subtracted from v square by 2 is equal to g into r, and then 1 minus cos of 60, which is 1 minus 1 by 2, which is 1 by 2 only, and then 2 and 2 gone, we will have v square plus gr is equal to u square, and v square itself is equal to gr. So we got gr plus gr, which is 2gr, and then root of it is equal to u. So the velocity will be root 2 times of gr, root 2 times of the root of gr, and root of gr itself is equal to v. So we got root 2 times of v, which is option number B. So B will be the answer, and this is how you can solve these types of questions. Today we are going to solve 9th question of PAVE exam. In this question it is saying the potential energy of a particle moving along x-axis is given by ux is equal to 3x minus x cube, where x represents the x coordinate of the particle in meters. This potential energy arises because of a conservative force. Assume that the particle to be moving under the influence of conservative force alone, and mass of the particle to be 4 kg. Answer the following question, and we have to choose the correct statements. First statement is saying the position of the stable equilibrium of the particle is at x is equal to 0. The position of the stable equilibrium of the particle is at x is equal to minus 1. These are two statements. Third is, if the particle is at x is equal to 1 and it is displaced either toward left or right, then it will move toward x is equal to 1 and x is equal to 0 is the position of neutral equilibrium. So we will solve this, and given is u is equal to 3x minus x cube. If we differentiate u with a negative sign with respect to x, minus of du by dx, this has to be equal to force, conservative force. So we'll write minus is equal to 3 is the displacement of 3x minus displacement of x cube is 3x square. This is equal to 3x square minus 3. Now if I put this is equal to 0, now f is equal to 0. For equilibrium we need f is equal to 0, that means 3x square minus 3 has to be equal to 0. That means x has to be equal to, x square has to be equal to 1. That means x is equal to plus or minus 1. These things we have got, plus or minus 1. Now at plus and at plus 1 and minus 1 both are the equilibrium condition, but if they are stable or unstable, that will depend upon the maximum or minimum of the graph. So what I will do is I will again differentiate the force. So I will just write df by dx, and I will get differentiation of that to be 6x minus 0. Now at this point, if I put x is equal to minus plus 1, I get 6, and then x is equal to minus 1 if I put df by dx is equal to 6x, and at x is equal to minus 1, I'm getting it as minus 6. Now at minus 6, you see x is equal to minus 6, df by dx is equal to minus 6. It is the position of it is the differentiation of f, and it is coming out to be negative. That means we are on this maximum part of the potential energy curve, and here it is coming out to be positive. That means we are at the minimum part of the potential energy curve. We know the minimum part is stable equilibrium and the maximum part is unstable equilibrium. So x is equal to 1 will be our stable equilibrium. So if we see x is equal to 0, it is the stable equilibrium, that is wrong. X is equal to 1, it is stable equilibrium, that is also wrong. And x is equal to 0 is neutral equilibrium, that we will talk about later. If the particle is at x is equal to 1 and it is displaced either toward left or right, then it will move toward x is equal to 1. That is correct. Why? Because at x is equal to 1 we got stable equilibrium, and in stable equilibrium if we move a particle rightward, it will come again back to the leftward, and if you move it leftward, it will come again back to the rightward. So x is equal to 1, this will happen. So this is equal to true. Now about the fourth point, it is the point of neutral equilibrium. At neutral equilibrium there should be no force on the particle. If you see x is equal to 0, if I put in this, I'll get the force to be equal to minus 3. That means it is not the point of neutral equilibrium. So C will be the answer, and this is how you can solve these types of questions. We are going to solve 10th question of PAVE exam. In this question it is saying the potential energy of a particle moving along x-axis is given by u is equal to 3x minus x cube, where x represents the x coordinate of particle in meters. This potential energy arises because of a conservative force. Assume that the particle to be moving under the influence of a conservative force alone. The mass of the particle is 4 kg. Answer of the following question we have to give, and we have to choose incorrect statement. So let's go with this. We are given that potential energy is equal to 3x minus x cube. If I differentiate this, I'll get du by dx, which is equal to minus of conservative force, which is equal to 3 minus 3x square. From here f comes out to be 3x square minus 3. Okay, now let's go for second statement. If the particle is released from 0, it will move toward minus x direction. So at x is equal to 0, force is equal to minus 3. That means negative force. That means it will go toward minus x direction. That is correct. If I put x is equal to minus 4, what will happen? It will be 3 into 16 minus 3, which is equal to 48, 3, which is 45. So x is equal to minus 4, it will go to positive direction. It is saying negative, that means it is wrong, and we have to choose wrong statement only. Let's go for D also. At x is equal to 4, it will move in positive direction. So f x is equal to 4 is equal to again 3 into 16 minus 3, which is 45, which is positive 4. That means it will move in positive direction. That is also true. Here it is saying between x is equal to minus root 3 and plus root 3, the maximum possible potential energy is equal to 2 joule when it occurs at x is equal to 1. So let's differentiate. We have differentiated this only, and we got here if we put f is equal to 0, we will get x is equal to plus or minus 1. That means it is either maximum or minimum at plus or either 1 or minus 1. So we'll just put x is equal to 1 here in potential energy, and we'll see the maximum value at x is equal to 1. So u max comes out to be 3 minus 1 q, which is equal to 2. So this is also true because the potential energy came out to be 2 joule. So incorrect is C only. So C will be your answer, and this is how you can solve these types of questions. We are going to solve 11th question of PAVE exam. In this question it is saying a ball A is thrown vertically up with a speed of 24 meter per second. At the same time another ball B is thrown horizontally from the tower as shown in the figure. Assuming 2D motion, find the speed of ball with which it will ensure that two balls will collide in air. So we'll take this figure, and you see here that if you see the motion of B, the ball is actually trying to go like this. B will try to go like this, and if you talk about A is trying to go like this. So motion of A will be a perfect straight line upward, and motion of B will be a curved parabolic motion, and they are striking here. What we are saying is we are already given that this distance, this total distance, this is 40. So I assume this to be x. So if this is x, this here will be 40 minus x. That means, and they are colliding at time t is t. So in t time, A has to go x meter upward, and B has to come 40 minus x meters downward. So I'll say 40 minus x is equal to, for B, downward velocity is 0, so we'll just write half of gt square, and for A, x is equal to 24t minus half gt square. Now if we add these two equations, what will happen? Here it will have be 40 is equal to 24 t. So t comes out to be 40 divided by 24. Now what do we want? That in the same time we go from here to here, which is 30 meters. So velocity of B, if I find velocity of B, it will be 30 divided by the velocity, which is 40, and here we have 24. Finding the value, 0 0 gone, 4 and then 6 into 3, which is 18 meter per second. That means B have to move with a velocity of 18 meter per second to collide, which is option number B. So answer is B, and this is how you can solve these types of questions. We are solving 12th question of PAVE exam. In this question it is saying on the rough table 3 blocks including the first block, this and this, are placed as shown in the figure. Mass of each block is m and coefficient of friction for each block is mu. A force F is applied on the first block as shown in the figure to move the system. The minimum value of F should be x mu mg. Find the value of x. So minimum value means it is about to move, so we have to move all the blocks. So if we talk about the first block, if it is trying to move, and it will move toward due to T3, and it will have a backward force of mu mg. So T3 has to be equal to mu mg, and being the same string, this string and this string will have same tension. This is T3, this is also T3. That means this tension will be 2 times of T3, which is same as 2 times of mu mg. Now second block, this is first, this is second, this is third. So second block, backward tension is 2 mu mg. Also backward friction will be mu mg. That means this tension, which is T2, has to be equal to 3 mu mg. Now if this tension is 3 mu mg, this is also 3 mu mg, this tension will be It's 2 times of T2, which is 6 mu mg. Now if you talk about M3, friction is equal to again mu mg, and backward tension is 6 times of mu mg. That means the force which is applied here, force has to be equal to 7 mu mg to move the system. That means x has to be equal to 7. This is how you can solve these types of questions. So we are going to solve 13th question of PAVE exam. In this question it is saying a particle moves in a circle having radius of 20 meters with a constant tangential acceleration of 5 meter per second square. The time in which the normal acceleration of the particle equals the tangential acceleration. Normal means centripetal acceleration. So if it is moving with a tangential acceleration of 5, velocity at any time will be 5 into t. We know tangential acceleration AC is equal to v square by r, which will be equal to 5t square by 20, and it has to be equal to tangential acceleration, which is 5t square by 20 is equal to 5. Now 5t square is basically 25 into t square is equal to, this will go there, it will become 100. This and this is 4, t is equal to 2. So at t is equal to 2 seconds, they will be same. So D will be the answer, and this is how you can solve these types of questions. We are going to solve 14th question of PAVE exam. In this question it is saying uniform rope of mass m and length t is initially held in the position shown. Now force is continuously applied to slowly pull the entire rope onto the smooth horizontal surface. What is the work done by pulling force during this process, given that mass is 6 kg and length is 6 meter? So initially our rope is like this, our string is like this. Finally what will happen? All the string will come up on the surface and will look like this. Finally it will become like this. This length is now L and the mass is. So you see there is no velocity available for the rope because it is pulled very slowly. There is no friction force also available. That means whatever force is available, that force's work will be equal to change in energy, but there is no kinetic energy. That means change in potential energy. So I'll say work is equal to change in potential energy. That means potential energy final minus potential energy initial. Final potential energy, assuming this is to be ground, so final potential energy is 0 itself. Initial potential energy we have to find. This mass down is equal to 2m by 3, and the center of mass's position is equal to L by 3 with a negative sign because it is downward. So work will be equal to 0 minus of potential energy. Why? Because it is downward, so it will be L by 3 into 2m by 3 into g. This minus minus becomes plus, so work done is basically equal to 2 mgl by 9. Now value of m is 6 and L is also 6. So we got 2 into 6 into 6 into 10 divided by 9. From here comes 3 gone 2, 3 gone 2, and then 3 into 3, 9 gone 1. So we got 2 into 2 into 2, which is 8 into 10, which is 80. So the work done by force will be equal to 80 joules. So D will be the answer, and this is how you can solve these types of questions. Now we are solving 15th question of PAVE exam. In this question it is saying boy is pulling the rope as shown below. Reading of weighing machine is. So you see, if we talk about this figure itself, when the boy is pulling the block upward, the block is having some tension there. Boy is having some same tension there. We can say the block is having some 5g force downward. So we'll say T minus 5g is equal to 5a. So T is equal to 5 into g plus a basically. A is 4, g is 10. So we got 14 into 5, which is 70. So tension is 70. So boy will have a tension 70 upward, and its own weight downward is equal to 200. So the normal on the boy here, normal will be equal to downward mg, which is 200, minus upward tension, which is 70, which is 130, and we know the reading of weighing machine is normal only, so answer A will be correct. And this is how you can solve these types of questions. Hello students, we are going to solve 16th question of PAVE exam. In this question it is saying the arrangement shown in the figure, all the strings and pulley are ideal. We have to find acceleration of block 5 kg, and this is our arrangement. So we'll take this figure. Now for solving this figure, let's start this. What we are saying is, assuming that here the tension is T, that means here the tension will be T, again T, again T, here it will be 2T. So tension on 5 kg block is 5T, and tension on this block, small block M, is T. Acceleration of these blocks I am saying is, for this it is acceleration A forward, and for this it is acceleration capital A down. We know tension is an internal force, so work done by internal force is 0. That means whatever T net dx integration we are talking, it has to be 0 for the system. Here this is the system, by the way. Similarly, I can say differentiation of that, which is T dv, also has to be 0. Similarly, differentiation of that, not dv, T into v integration, that is sum, and similarly T into A is also has to be 0. So for this block, if you say T into A is TA only, so we'll write there T, and then for this block it is tension is 2T, this is 2T, and then this is T. So total tension on the 5 kg block becomes 3T. So we'll say 3T, sorry, I'll use pen, 3T into acceleration is downwards, so we'll write minus 3T, it has to be equal to 0. From here we get small a is equal to 3 times of capital A. That is one equation we got. Second, what I'm saying is, for this block, the bigger block, upward force is 3T, downward force is 5 times of mg. So 5 mg minus 3T has to be equal to mass into acceleration, which is 5m into A. Done. Now, and for the smaller block, if I write, it will be T is equal to ma straight. Why? Because there is no extra other force acting. So from here T, if I substitute, I get 5 mg minus 3T, which is 3 times of ma, is equal to 5 times of m into A. From here A we already got is equal to 3A, so we can write 5 mg minus 3m into 3A is equal to 5 ma. From here 5 mg is equal to 3 into 3 is 9, so we got 9 ma, and this is 5 ma, it becomes 14 ma. M and m is gone, we got A is equal to 5 by 14 g. So that will be the acceleration of our bigger block. 5 by 14 g is available in option number A, so A will be the answer, and this is how you can solve these types of questions. We are going to solve question number 17 of PAVE exam. In this question it is saying a car starting from rest accelerates at a rate of f through a distance of s, then continues at a constant speed for time 2t, and then decelerates at a rate of f by 3 to come to rest. The total distance traveled is 16s. Then we have to find the relation between s, t and f. So we are saying that it started the motion like this. It went till this distance, the total distance is 16s. It covered this distance s with an acceleration of f. Then after that it went for a time 2t. So this time is equal to 2t with constant velocity. So I'll say it is some v. And then the rest distance it covered with a retardation of f by 3. So we got this. Now this time is 2t. So we will just find all the distance and then add them up, and then we will be having our solution. So total distance is 16s that we already got. It has to be equal to s, which comes from here. This velocity will be due to this acceleration and the time taken here. So if acceleration is s, I can say time is equal to, we know distance is equal to ut plus half a square. U is 0, so we got half f t square, whatever t it is, let's say it's capital T square. So we got capital T is equal to 2s by f in a root. That means the velocity which we will be getting here is this v will be equal to v square is equal to u square plus 2as, and from here v will be 2fs root. So this is equal to 2fs root, and this is traveled for 2t time, so we'll say it is s plus 2fs root into time, which is equal to 2t plus. Now with this velocity, it is coming to velocity of 0 with a retardation of f by 3. So I'll say again the distance traveled is equal to again v square u square and then 2a. So we got v square finally is 0 minus u square, which is 2fs. It has to be equal to 2a and into acceleration. So 2a into distance. So 2 times of acceleration of minus of f by 3, and distance I'll say it is equal to d. Now from here 2 and 2 is gone, f and f is gone, we'll have 3s is equal to d. So the next distance is equal to 3s. Now from here if I find what are the relations are, so you see s and s is 3s plus s is 4s, so 4s will go there, we'll have 12s is equal to 2fs root into 2t, 2 and 2 is gone, we'll have 6s. So we'll have here 6s divided by 2fs in the root is equal to t. Take a square on both sides, we'll have 36s square divided by 2fs is equal to t square. From here 1s gone and 36 and 2 is gone, we'll have 18. So we got t square is equal to 18s by f. We need the relation of s, so we'll have s is equal to ft square by 18. Ft square by 18 is available in option number D, so D will be the answer, and this is how you can solve these types of questions. We are going to solve question number 18 from PAVE exam. In this question it is saying find the acceleration of 5 kg block. See 4 kg block, the friction coefficient is here is 0.5, here is 0.3, this is 5 kg block, and 4 kg applied by 40 kg of 40 Newton of force. So for 4 kg if we talk about, this force is 40, downward force is also 40, upward force is normal, this direction friction will be available. If we go for maximum value of friction, it is F is equal to mu into L, which is 40 into 0.5, which is 20 Newton. That means because of this 40 it will move surely, but this friction will be applicable on 5 kg also. Now if we talk about 5 kg, this is 20 Newton. Downward there is a force due to 4 kg, the normal. Upward there is a force, its own normal from ground, and its own weight is 50, and it will also applied by a friction F due to ground. So normal will be equal to 90, by the way. F max will be equal to 90 into 0.3, which is equal to 27 Newton. So this force on 5 kg can go up to 27 Newton, and the force applied by 4 kg as friction on it is equal to 20. That means this force will be able to block it completely, so 5 kg will not be even moving at all. So acceleration of 5 kg will be 0 meter per second square. So answer is 0, and this is how you can solve these types of questions. We are going to solve 19th question of PAVE exam. In this question it is saying mu is the coefficient of friction between all the surfaces. Block A is kept over block B on the inclined plane. The minimum force required such that A block can accelerate along the applied force is mg sin theta plus n into mu mg cos theta. We have to find the value of m. So if we take this system, now if we draw all the forces acting on these blocks when they try to move, you see here is one tension. This guy will have its own mg sin theta this direction, and it will have a friction backward. Here it will have a friction backward, and that friction will be equal to mu mg cos theta. Why is this friction backward? Because it is trying to go forward, and if this tries to go forward, this string will go forward, this will come backward. That means this block will come backward. That means it will have a friction backward. So if I draw the friction on this bigger block, its friction will be this direction, and the friction's value will be normal, which is 3 mg cos theta into mu. Also, due to this friction, it will also have a friction backward, which is mu mg cos theta. Also, it will have its own weight, which is 2 mg sin theta, and a tension acting on it. We want the smaller block to move anyhow, so we'll say the equilibrium, the approximate force acting on the bodies are almost zero. So we'll say for 2 mg, if I talk about tension is upward, so tension downward force is 2 mg, in this 4 mu mg cos theta. So we got 2 mg sin theta is 4 mu mg cos theta, and for this we have to write tension upward mg sin theta, force and mu backward. So we'll write T is equal to F plus mg sin theta minus of mu mg cos theta. Now this tension has to go there, so from there we will write F is equal to 2 mg sin theta plus 4 mg cos theta mu minus of mg sin theta plus mu mg cos theta. Mg sin theta and 2 mg sin theta, it will be only 1 mg sin theta, so we'll write there mg sin theta plus 4 mu mg cos theta plus mu mg cos theta. We got 5 mu mg cos theta, that is equal to force. So this much force we require. So this, if we equal them now, mg sin theta is mg sin theta, and n mu mg cos theta is 5 mu mg cos theta, so n is equal to 5. 5 will be the answer, and this is how we can solve these types of questions. Now we are going to solve 20th question of PAVE exam. In this question it is saying the acceleration of a particle is increasing linearly with time as bt. The particle starts from origin with a velocity of v0. The distance traveled by the particle in time t is. So what we are saying is acceleration A is equal to bt. We know acceleration is equal to dv by dt is equal to bt. So from here dv's integration will be equal to dt dt's integration. Dv's integration is equal to delta v, which I will say is from v0 to v, and that is dt square by 2 from 0 to t. So we got v is equal to v0 plus bt square by 2. Now v is basically equal to dx by dt is equal to v0 plus bt square by 2. From here dx is equal to v0 plus bt square by 2 dt. Integration, it is starting from 0, so we got x is equal to v0 t plus bt cube. 2 was already there and 3, so it got 6. So we have v0 t plus bt cube by 6 is equal to x. This much distance it is traveling, which is in option number C. So C will be the answer, and this is how you can solve these types of questions. Now we are going to solve 21st question of PAVE exam. In this question it is saying a particle of mass 10 by 7 kg is moving in a positive direction x. If the initial position of the particle at x is equal to 0 and initial velocity is 1 meter per second, the velocity at x is equal to 10, we have to find. So the graph is given between power and displacement. We know that our power is equal to dw by dt, which is work by time. It is equal to f dx by dt. Wait a moment, f dx by dt, and f is equal to m v dv by dx into, wait a moment, I'll write it here, v dv by dx into mass into dx by dt, that is equal to p. Now here, from here you see, if I do p dx, it will be m v dv dx by dt. And what is dx by dt? Is v again, so we got p dx is equal to mv square dx. Integration, if I do, p dx is integration, which is area under Ex graph, and it is equal to mv cube by 3 u2v, which will give me mv cube minus u cube is equal to area. Area of this graph, if I find it's a trapezium, so area will be this one, which is equal to 2 plus 4 into 10 by 2. 2 plus 4, sum of parallel height, into 10, which is height by 2. So 2 plus 4 into 10 by 2, which will be equal to 30. What we can say is 30 is equal to m, which is 10 by 7. So we got 10 by 7 into v cube, that is the final velocity, minus 1 cube, which is initial velocity, into 3. So from here this is gone, this will go there. We will have v cube is equal to 21 into 3 and then plus 1. Root of cube root of it will be equal to v. So we got 21 into 3 is 63, plus 1 is 64. 64's cube root is equal to 4. That means velocity at 8 will be 4 meter per second, which is option number A. So A will be the answer, and this is how you can solve these types of questions. We are going to solve 22nd question of PAVE exam. In this question, it is saying the variation of velocity of a particle moving along a straight line with time is illustrated in the adjoining figure. We have to find distance traveled by particle. We know that if velocity is given, distance in straight line, distance is same as displacement. So whatever distance it is the area of this graph. So we have to find the total area of the graph. So first is area of this one, this triangle. Area of this triangle will be basically, just a moment. Area of this triangle will be this, which is 20 plus 1 by 2, which is 10 plus. Then area of this rectangle, which is 20 into 2 only, 20 into 1, sorry, which is 20. And then this area of this trapezium, area of trapezium will be this side, which is 10 plus 20 into 1 by 2, which is 50, plus area of this square, so not square, again the rectangle it is. So area of this rectangle will be this side, which is 10 plus 1, which is 10. So we got 10 plus 20, 30, 30 plus 10, 40, 40 plus 15 is equal to 50. So the distance traveled is 55 meters. So B will be the answer, and this is how you can solve these types of questions. Now we are going to solve 23rd question of PAVE exam. In this question it is saying a block is released from the rest from the point P having coordinate of minus 9, comma 9, so that it slides down along the fixed smooth parabolic path y is equal to x square by 9 shown in the figure. Given that the mass of the ball is 5 kg, find a normal reaction of the ball from the path when it reaches the bottom of the path, assuming g is equal to 10. So here, this is the bottom. Wait a minute. When the ball is here, we have to find its normal. Normal is upward force. Downward will be mg, and if the ball is coming here now, what happens is it is traveling with the velocity v, and assuming there is some radius of curvature available, so downward will be a pseudo force of mv square by r. That is more important. So first we will find the pseudo force. It is given as y is equal to x square by 9. If I differentiate this y, I get dy by dt is equal to 2 times of x into dx by dt by 9. What is dx by dt? It is basically velocity along x-axis, and this is velocity along y-axis. If I differentiate this again, I get acceleration along y-axis, which is equal to 2 into differentiation of x will give me vx again by 9, plus velocity differentiation, it will give me 2x ax by 9. Now when the particle reaches at this point, x is equal to 0. So this thing is gone at x is equal to 0. Acceleration along y will be 2 v square by 9, vx square by 9. So if I have the velocity along, x-axis, I can have my answer. So velocity along x-axis we have to find. The particle was released from this position. This position. This is -9 and this is +9. -9 +9. Y is equal to +9. From here it is released and it is coming at a ground level. That means it is coming 9 meter down. So work will be done by gravity and velocity will be calculated. So let's say half mv square final kinetic energy minus initial kinetic energy is equal to work done by gravity, which is mgh, which is m into g into 9. M and M is gone. We have Vx square is equal to 2 into G into 9, which is 180. So I'll have acceleration y is equal to 2 into V square, which is 180 by 9. 9 and this is gone. We'll have 200. Not sorry, not 200. I'm sorry. This is 180 by 9, which is 20. 20 into 2 we'll have 40. So this is the acceleration, the pseudo force acceleration v square by r we already got. We have to multiply this by mass. So mass of the body is 5. So we get pseudo force fp is equal to mass into acceleration in y direction, which is equal to 40 into 5, which is 200 Newton, and weight of the body is 5 into g, which is 50. mg is equal to 50. That means the total normal will be equal to this plus this, which is 250 Newton. So option number C is giving us 250 Newton. So C will be the answer, and this is how we can solve these types of questions. Now we are going to solve 24th question of PAVE exam. In this question, the value of F so as to keep the smooth wedge stationary when it is loaded with a block of mass M, which is connected with a light inaccessible string, will be. So for this block, if you see, in that direction the force will be under sin theta. Upward will be tension. It will be applying a force downward of mg cos theta. What we are saying is the bigger wedge, which is like this, it is being applied by a force of mg cos theta here, the force here and theta here. It should be stationary. You see, the angle here will be theta again. So what I was saying is, this force will be broken into two parts. Downward will be mg cos theta, and this direction force will be mg cos theta sin theta. So force has to be equal to this force. So we will say it is F is equal to mg sin theta cos theta, which can be written as 2 and 2 divided multiplied. This will be sin of theta by 2. Sin of 2 theta will have F is equal to mg by 2 sin of 2 theta. This is option number B. So B will be the answer, and this is how you can solve these types of questions. We are going to solve the 25th last question of this PAVE exam question paper. In this question, it is saying a ball attached to one end of a string swing in a vertical plane such as its acceleration at point A here is equal to its acceleration as point B here. The angle theta we have to find. You see, say this is our figure. What I'm saying is, assume that here the velocity is v and here the velocity has become 0. So how much it has gone up? We already know that this distance is equal to r cos theta, so this will be r1 minus cos theta. Gravity is doing work, so 0 minus half mv square is equal to mg going up, so it will be minus of mg r1 minus cos of theta. From here, mv square by 2 is equal to mgr 1 minus cos of theta. That is the one point. Now if I find acceleration at this point, so particle is going with the velocity of v, velocity radius is r, so centripetal acceleration will be v square by r, which is from here will be equal to 2g1 minus cos of theta. Done. At this moment, if you see the particle is not moving, so centripetal acceleration is not available. This angle is theta, so here will be mg cos theta, in this direction will be mg sin theta. So acceleration at the maximum point will be g sin theta, and they both have to be equal. So g 2g 1 minus cos theta is equal to g sin theta. If we solve this, we get 2g 1 minus cos theta is same as 2 sin square theta by 2. It is equal to g into 2 sin theta by 2 cos theta by 2. Now from here 2 gone, sin theta by 2 1 sin theta by 2 gone, g and g gone. What do we have is cos theta by 2 is equal to, oh no, sorry, we have 2 into sin theta by 2 is equal to cos theta by 2. From here we get tan theta by 2 is equal to 1 by 2. All the answers are in the form of cos theta, so we'll again write it. We will have, if tan theta is this, we can have sin theta by 2 is equal to 1 divided by 2 square plus 1 root, which is root of 5. And then from here, if I find cos theta, I will have cos theta is equal to 1 minus 2 sin square theta by 2. So sin square theta by 2, sin square if I do, it will be 1 by 5, and then 2 times of that is 2 sin square, which is this, and then it has to be subtracted from 1, so will be 1 minus 2 by 5, which is 3 by 5. From here theta will be equal to cos inverse of 3 by 5. So theta will be equal to cos inverse 3 by 5, which is option number C. So C is the answer, and this is how you can solve these types of questions. Thank you.